Hello everyone, thank you for joining us today. Just to allow more people to join, we will be going live in 2 minutes, so we will see you then. Good morning, good afternoon, and good evening to wherever you are dialing in from. My name's George, the editor of Solar Media's UK-based publications Current and Solar Power portal, and welcome to the latest edition in our Current Briefings webinar series, where today we'll be talking about understanding vehicle-to-grid interconnection standards for bi-directional charging stations. I'm delighted to say that I'm joined today by Mike Becker, Manager of Market Analytics at CSA Group. Good afternoon, Mike, and thank you for taking the time to be here today. Now, in just a moment, I will be handing over to Mike, but before that, I'd just like to mention that we will have some time allocated at the end of the session for audience questions. So please do stick around until then, and we will make sure that your questions are answered. To ensure that we see these, please type them in the questions box in the bottom right-hand corner of the screen throughout the webinar. Now, without further ado, I will hand over to Mike. Hello, Mike.
Hi, George. Thanks for the introduction. All right, let's get started. Welcome, everyone. Like George mentioned, thanks for joining our webinar. So we're going to be talking about vehicle-to-grid interconnection standards for bidirectional charging stations. And so we'll touch on a few aspects of this. Just a quick introduction on myself. So I have an extensive background in regulatory and new product development. Started more on the battery side, so participated in product development for battery systems targeted for energy storage, motive power, and then also backup power. I've also participated in standards development activities for energy storage system standards like UL 9540 and also NFP 855. And then more recently, in the past probably year or two, navigated more on the side of EVSE and also inverter standards, and helped design and get our new lab built to be able to test these products and to the standards that we're going to talk about. Okay, so just a quick agenda note of the different topics we're going to cover. We'll first talk about some of the basic safety standards in both North America and Europe. So although those aren't V2G necessarily related, if you're manufacturers of products for EVSE, you still will need to comply with the safety standards. So I'll touch on those first and then go into the V2G integration and grid interconnection standards. Also talk about interoperability, which is a big topic for bidirectional chargers. And then finally, just touch on CSA's Distributed Energy Resource Lab, some of the highlights of our lab, what can we test and what type of services we provide. And so I'll just touch on that at the end. All right. So starting with the applicable safety standards for electric vehicle supply equipment, or EVSE, as I'll reference it throughout the presentation. So the standards that are applicable to these types of products really vary based on the type of charger that you're designing that needs to go through certification. So kind of touching on three different categories in this slide. The first one is DC fast chargers or DC electric vehicle chargers, and that would fall under UL 2202. And there's also, that's harmonized with the CSA standard. So this covers products supplied by brand circuits up to 600 volts, and the scope includes products delivering DC power directly to EV batteries. So this would be portable charging units, onboard electric vehicle chargers, and then commonly DC fast chargers. So those are the level 3 chargers that are installed publicly in the field. The next category is more on the AC charger side. So that's UL 2594 and the equivalent CSA number. This covers products delivering AC power to the electric vehicle. So this would cover residential EV charger cord sets, and then also movable and permanent EV charge stations that are using AC circuits to deliver power to the vehicle. So those are the two major categories, DC and AC chargers, and then the two safety standards that apply in North America. There's also UL 2750 and the harmonized CSA standard, which covers wireless power transfer. So this is for EV chargers that deliver power wirelessly through induction or another means. It's not really widely adopted yet and not commonly used. There has been some development recently in that space, but not really deployed on a large scale yet. But that is a standard for it. All right, moving on to the European market. So there's a series of standards, the IEC 61851. This is the safety standard series for electric vehicle charging equipment, specifically conductive charging, so things that plug in. And then so there's the main part, which contains the general requirements -1 for all EV chargers. And this covers all 4 modes of charging, which is broken up similar to the other standards into AC charging, with a plug-in, a cord, or a permanently connected AC charger, or then the mode 4 being a DC supplier, DC fast charger. There's also specific requirements for DC charging stations in -23, and then also requirements for the communication between the EV and the DC charging system in -24. So those are kind of the two main categories for safety standards, the IEC 61851, and then those UL standards that we considered, which gives you a better picture into North America and then also Europe. Okay, so those are mainly safety standards. So those are certification, typical electrical safety. Now we're going to transition more into the vehicle to grid integration and some of the standards that are covered in those technologies. So just to briefly explain vehicle to grid, or V2G as you commonly hear, this utilizes bidirectional charging capabilities of both the EVSE, the EV charger, and the electric vehicle to export power to the grid. So the power could be used locally in residential applications, maybe a local load, or as backup power in a residential installation, or it could also be used to support the overall grid locally or more broadly, a larger scale. Perform similar functions as larger energy storage systems that may be used for grid support. So a lot of times those are used for reducing demand charges, frequency regulation, backup support. And so they perform the same function as a larger battery system, but they're just smaller batteries in an EV that could be aggregated together. It also may be used for personal EVs along with commercial applications such as truck and bus depots. So that's another major use of V2G because you have major bus depots where the buses may not be being used, and those are a lot larger batteries, and so they can also support the grid. So the one thing with these applications is that they do require the charger, the EVSE, and the EV to interact with the grid, similar to a backup generation, such as a generator or ESS. So we'll talk more about what that means when we say about interacting with the grid, which is really where this is coming into play. So these are some of the standards that refer to the V2G interconnection requirements. So these are the requirements when I reference interacting with the grid of what's needed here. So the main one that has been more recently released and updated is the UL 9741, or the equivalent CSA standard, the 348. This covers electric vehicle power export equipment. So the scope of this standard is the offboard equipment that transfers electrical energy from an EV to local loads or the grid. So this addresses equipment that can be supplied AC power directly by an EV that uses onboard interactive inverters as well. So this covers if you have an EV charging station that can accept power from an electric vehicle, convert it back into AC power, and then export to the grid. That's what this standard covers, those type of devices. It also covers devices that sometimes in an electric vehicle, instead of exporting DC power, may export AC power directly out of it, and then this device would pass that along to the grid and also monitor several things. So this standard covers those types of devices. Another standard that really comes into play is the UL 1741, which is harmonized with the CSA 107.1, and this requirement comes into play for utility grid interactive products within UL 9741. So UL 9741 could cover products that export just to local loads, so it's not actually exporting to the grid. But if you are exporting to the grid, interfacing with the utility connection, then you would have to comply with UL 1741. And so this type of compliance is looked for by utilities when submitting like an interconnection application for larger installations. So if you install an energy storage system and there's an interconnection application, they're usually looking for compliance to UL 1741 because it denotes that this interaction with the grid has been checked. So within 1741, there's two supplements, Supplement A and Supplement B, which are where really the important requirements are for grid interaction. So this covers grid support utility interactive equipment using requirements in some of the IEEE standards, the 1547 and the 1547.1 and the testing in there. So what's in these supplements or the standard? Well, it addresses grid interaction functionality such as voltage, frequency, or power factor ride-through conditions. So what that means is that if you're connected to the grid, there may be fluctuations in the grid. Maybe voltage goes high or low, or frequency drifts, or there's different power factor changes. And so what the supplements checked is how does that bi-directional EV charging station react to those conditions? So in some cases, it may need to ride through it, which means it can't shut off. It needs to continue to function if there's a drift in frequency, let's say, for instance. In some cases, it's required to shut off. So if voltage goes above or below a certain range, it needs to disconnect from the grid. So that's what these supplements are really checking, that if the grid does certain things that isn't normal, isn't nominal, that the EV charging station reacts appropriately if it is exporting power to the grid. And then finally, just to touch on a final standard, SAE J3072. This was more brought into play for electric vehicles that had onboard inverters that were going to export to the grid. And so this covers requirements for a grid interactive system onboarded on an actual electric vehicle that's used in conjunction with the IEEE standards as well. So again, the EVSE in this case isn't actually doing the power conversion. It isn't doing the DC to AC conversion. It's just taking the AC power from the electric vehicle and passing that along to the grid. And so these are commonly referred to as interconnection system equipment, or ISE, because in that case, it's just a box that's interconnection. There's some monitoring and other things that it's being used for, but that's kind of the general gist of it. Okay, and then so those are more of the interaction with the grid requirements. Now just touching briefly on interoperability. So there's the communication standards. Some of the popular ones most might be aware of is the ISO 15118-20, which is the communication standard for defining messages between the EVSE and the electric vehicle. And there's various functionality that's built into that protocol, such as the bidirectional power transfer, the automated connection devices, and then also the wireless power transfer. So this is definitely one of the popular communication standards, and that's becoming more frequently adopted. There's also the DIN 70121 and 122, which are also communication protocols for DC charging for EVSE and EVs. And there are growing efforts to transition from these standards to the ISO 15118 instead of using these specs. So that's kind of a different discussion, but there are changes that are being worked on for these interoperability standards. There's also OpenADR, which provides a communication protocol from the utility to these energy using devices for management. So what this is used for is if the utility wants to send signals to a bidirectional EV charging station of maybe what the price of electricity is at that time, alerts, grid code adjustments, demand response notifications if there's going to be a demand response event. So this allows a communication protocol for the utility company themselves to communicate with the product. There's also OCPP 2.0.1, which is, I think this is the latest revision, or Open Charge Point Protocol. And so this addresses communication between a charging station and a charging station management system. So usually there's a back-end part of these systems where there's communication between this back-end and the devices that are installed locally. And some of these considerations include security, communication of secure information from the charging station to a cloud, and also 15118 has a plug-in charge capability to allow automatic authentication, and so that's what is also covered in here. And then finally, there's the IEEE 2030.5, or the SunSpec Common Smart Inverter Profile, and this is also another communication protocol that's commonly used for utility management of these energy-using devices like demand response, load control, electric vehicles. So it allows the utility to have involvement and communication and some control of these installations. Okay, so that's kind of an overview of the standards. I know it's a lot of numbers thrown out there, but at least gives you an overview of what is applied, when it's applied, and of course, as George mentioned, we're open for questions at the end, and we'll also follow up on questions that we're not able to cover. So now transitioning over to our specific capabilities when it comes to CSA testing capabilities. We have recently built a distributed energy resources, or a DER lab in Cleveland, Ohio. And originally the testing that we focused on was more battery focused. So vibration testing, overcharge testing. We also had battery fire testing like thermal runaway. We could do large thermal runaway fire testing, nail penetration, and other custom tests. And so some of the standards that we targeted include standards for energy storage systems like 9540, 9540A, but then also testing for some of the electric vehicle battery packs like the ECR 100, which covers various abuses of batteries. So that was the first phase of development, and then we had an expansion where we added additional testing capability for electric vehicle supply equipment and grid interactive inverters. And so now that is installed and operational, we can test EVSE and inverters up to 500 kilowatts. And then we also added equipment that serves as the communication simulator, simulates the electric vehicle battery, AC grid emulators where we can simulate those grid variations, and then also an environmental chamber to simulate various environmental conditions, hot conditions, cold conditions, and see how the electric vehicle charging station reacts to that. So just an overview of some of the typical equipment that's used in testing of these stations, especially when we're talking about some of those standards, safety standards, and also the communication standards, even the grid standards. So this is some of the equipment that we purchased for our lab that has been installed. We have a communication bridge between the electric vehicle and the EVSE. So what this does is it simulates that communication protocol from the electric vehicle that the EVSE is expecting to see to do a charging cycle. And this can do a lot of the different protocols, not just one of them, but a lot of them, and a lot of different connectors as well. We also have the DC emulator, and so the purpose of this is to simulate that EV battery. So this provides the EV battery simulation for this type of system, and it's bidirectional, so it can accept power, which would basically be simulating a charging event, and it can also supply or export power, which would be simulating that vehicle to grid application. So with this type of setup, we're able to do bidirectional power flow, testing EV charging stations that are unidirectional or also bidirectional. We also have the regenerative AC emulator. Again, this is bidirectional, and it also can simulate a lot of those grid disturbances that I talked about earlier. So it can do different voltage fluctuations, frequency fluctuations, and determine how the EV charging station reacts to those conditions as required per those standards. And then finally, we have a large walk-in chamber, again, that we can put an entire charger inside, even some of the larger ones, to be able to simulate various environmental conditions. Okay, so just briefly touching on, we're coming to the end of the presentation, just how kind of a project works, especially with certification in general, but also CSA. And some people may be unfamiliar with how a certification project works. This just gives a nice general overview of how we would run a project. So we have a project planning stage. We do an initial design review of the product, and then we do our lab testing. We review the results of that lab testing. We're able to create then a draft report, which documents all of the different critical safety components of the product, the test results, all the information about the product, and then we make a final decision and allow for certification. And so that's when, at least for the safety side, when you see the safety marks on the products, this is the process it goes through to be able to apply that mark on a product to say that it has been certified and meets the applicable safety standards. And then finally, this is just an overview of what are various services that we can offer. So of course, this presentation focused mostly on those safety standards and then also the interconnection requirements for EV charging stations. But we also have a large breadth of services when it comes to global market access. If you need help getting into other countries besides Europe and North America, as I talked about, cybersecurity, which is becoming an important topic in this space, consumer product evaluation. We also do energy efficiency, which also can be applicable for these charging stations, functional safety, and also field evaluation or special inspection, which is more meant for small runs of products. So if you're installing a few products at an installation site and you don't want to go through the whole certification process, there are ways to evaluate a single installation. And I think that brings us to the end.
Brilliant. Well, thank you, Mike. A lot of information to digest there, so I'm sure everyone came away from it with a lot learned, essentially. So, as Mike said, we'll now be moving into the Q&A session. Now, I see we've got a few questions that have already come in, but please do make sure everyone there, do ask a question, put Mike to the sword. But just to get things started, I've got a few questions just to ask you, Mike. So, one that I like to ask people is, do you see the future being AC or DC for vehicle to grid?
Yeah, it's a good question. I think it depends on the installation itself. So I've seen applications where if there's other on-site DC devices, let's say solar installations, energy storage systems like other batteries, or there are other EV charging stations, then there are benefits to having a DC localized DC connection, and then having one conversion point for AC to the grid, just better efficiencies in some of those cases. But where there isn't other DC devices, there isn't a ton of advantage to having a DC output, because you'd have to convert it anyway. So I think it depends on what other devices, and some of them have kind of a whole ecosystem of renewable products, and in some of those cases it might make sense.
Brilliant, thank you. So the next one I have is an interesting one to ask different people. So when do you actually think vehicle to grid will be readily available to the market?
Yeah, that's a good question. I don't know if I can speak to exactly when specific types of products will be released, but I think in general, it really depends on multiple aspects. You have the one side where you have the EV chargers themselves, which need to be able to support this. So it depends on their adoption of some of these newer standards, on being able to do the grid interconnection requirements as well. But it also depends on the electric vehicle manufacturers as well. They need to be able to provide that capability and also implement the correct communication protocols for everything to work seamlessly together. So there are definitely efforts to perform that testing, perform that integration that I've seen recently. So I think it's definitely going to become more popular as additional testing and products come out that support this capability.
Absolutely. Now, the last one I have before we move on to the audience questions is around security. Is there anything you'd like to add about cybersecurity, especially when you're thinking about vehicle to grid?
Yeah, it's definitely become a hot topic recently. I think I read a stat previously where a lot of the actual cybersecurity incidents, especially in Europe, have been on EV charging events and occurrences, and so there's a lot of work being done to add a lot of cybersecurity elements to some of the communication standards that I talked about. So a lot of those are adding security elements to make sure that everything is being done state of the art. Latest and greatest security authentication is being done both on locally on the charger itself and then also on the back end. So I think it's something initially wasn't really thought about or implemented, but is definitely being updated in a lot of these standards to be included as something that needs to be looked at.
Brilliant. Thank you, Mike. So that's all the questions I had. So we'll move on to the audience questions now. So Denise Onder asked, is there a specific standard that ensures the charger to connect and deliver to ancillary services?
So, yeah, it's a good question. It depends, I think, on what we're referencing as far as the application. Again, the standards, you have the safety ones, you have the interconnection ones, you have the communication ones, and then there's also standards around accuracy of billing for these. If we're talking about ancillary services, I think I would probably point to the UL 9741 in the equivalent CSA standard because that's basically checking that the EVSE can export power to a local installation. There's also different considerations for vehicle to grid versus vehicle to home versus vehicle to load. So it depends on the application of how it's being used. But there's definitely requirements out there.
Brilliant. So Eric Brown asks, what implications are there on standards if there is an aggregator involved?
Yeah, so that's a good question. So it really, some of those cases can be a little confusing because it comes down to, for the safety side, it comes down to when it's being inspected by usually somebody. You have a local code inspector that's inspecting the products. That cares mostly about the product. It's not really looking at how it's being aggregated or how it's being installed on a larger scale. I think that's where some of those other communication standards will come into play. So you have like the OCPP standard, which is for the charging management system. A lot of times an aggregator will use that type of system to have all the data for an entire site and then pass that along. And that's where some of those cybersecurity elements may come into play. So as far as from the safety and grid interconnection side, there's not a ton I think aggregators would need to be concerned about, but probably from the communication side. Unless you're the one responsible for doing the interconnection application to the utility, then you'll need to make sure that you have all of those requirements met because they're going to ask for that.
Gotcha. So moving back to the AC and DC question. So Michael Hallett asks, how do the efficiencies compare between AC and DC bi-directionally?
Yeah, so that's an interesting question. I don't know if I'm going to have exact numbers for you, but based on past experiences and doing new product design, there seem to be better efficiencies for, let's say, a DC to DC conversion versus a DC to AC conversion if you have it at multiple points. So just based on previous experience, it seemed to be the better route to have if there's other local DC sources, like I mentioned, like solar, battery systems, that it was more efficient to have DC to DC conversion to match it to a common DC bus and then do one final conversion to AC to the grid. So that's a good question. I don't have exact numbers for you, but that was just based on previous experience that's what we found to be the case.
Perfect. So Tessa Hillen asks, how many certified vehicle to grid enabled chargers are available on the market today?
So I'd have to check the databases. So when a charger gets certified to these standards, it does have to get listed on the certification agency's website. So if you go on CSA's website, other certification labs, you can find if they're certified product. I will say that last time I checked, there wasn't a lot. There was probably under 5, if I'm being honest, of chargers available because it was a newer standard that has been released. and it's definitely something that's being considered, but is newer in the space. So I think it's probably a low number compared to just unidirectional DC charging stations, but we're expecting to see an increase in evaluations of those types of products.
Gotcha. So the next question comes from Attili von Henning. So why are these grid interconnection standards required for bidirectional chargers?
Yeah, so this really comes into play for protecting, one is protecting the utility equipment. So the utility doesn't want product exporting to the grid that isn't following their specific standards, because if you're exporting some crazy power factor or voltage or frequency, it can have bad effects on the utility equipment. And it's also for other users of that power. So you can see in a residential application, if you're exporting power, your neighbor might be using that power. And so their devices have a specific input rating. And if you're not exporting the correct power, then their devices could get affected negatively. So it's really to ensure that the power quality, both back to the utility and other users of that power, are getting the right ratings and not damaging their equipment.
Brilliant, thank you. So Stephen Roberts asks, how realistic is vehicle to grid in terms of ROI and cost versus benefit?
Yeah, that's a good question. I think it would depend on, I think, the type of installation. Some of these installations where you have larger scale, like I brought up before, like the bus depots, yeah, there could be better ROIs there, because to participate in some of the utility events, demand response, frequency regulation, you need to have a lot of capacity. And a single residential, single passenger EV isn't going to have that type of capacity. So in those, it might make more sense because you're able to aggregate 20 buses together and be able to provide a good amount of power. For residential application, it's almost more, you have to look at it from more of the resiliency standpoint, where maybe you're not really considering the ROI, but I mean, when you buy like a generator for your house, there's not really an ROI you're looking at. You just want peace of mind and resiliency that if the power goes out, you're going to have power. And so in those cases, I could see it's just a different mindset for a home owner, maybe looking at it more from, I just want resiliency rather than necessarily participating in utility events to make money.
Brilliant, thank you. So Dennis DeCalla asks, some EVs have V2L capability now, so they can run on a domestic appliance with AC output. They ask, is that output suitable also for vehicle to grid?
So the way that the standard is considered right now, so the ones that we talked about, there are actually different requirements depending on those applications. So there are requirements for V2L. So like usually for those devices, you have a plug that goes into the EV and then maybe just a standard outlet at the other end of it. So there are different requirements for that than to be used for a V2G or even vehicle to home. So usually I would say no, that if it's meant for a vehicle to load, it's probably not verifying all those other grid capabilities because you're not exporting anything. So usually there's going to be a more requirements to consider with those.
Brilliant, thank you. So our next question comes from Tessa Hillen, who asks, are there any relevant locational specifications in these standards, or are they standardized across the globe?
So they're probably, I don't know if I would say they're standardized across the globe because there could always be jurisdictional differerences depending on where you install it. Just one example is some of the interconnection requirements with like the UL 1741 SASB. There's different states that adopt different versions of the standard, or they could adopt the standard, but then maybe have small differences in what they're looking for. So there are efforts that when we're talking about the UL 1741, like the supplements, to get all the utilities kind of on the same page. So they're all requiring the same thing. But in the end, it's up to each utility company to adopt their own standards, and nobody really has control over that. So in the end, the standards are good starting points, and they'll probably cover most areas that are further along in adoption. But some of the other ones, there could always be differences depending on what the utility company wants to see.
Brilliant, thank you. So Michael Hallett asked, you spoke about functional safety. Is this required formally for the charger, for example, to 61508/26262?
Yep.
If so, what SIL, ASIL left is required?
Okay. Yeah, that's an excellent question. So there are functional safety elements to EV chargers. They specifically apply to parts of the chargers and functions of the charger. So one popular one is like an installation monitoring device. So to make sure that if there's an installation fault, it's able to detect it. So usually you're using some type of device or circuit to do that. And so those requirements might fall under like a 61508. Also, there are some of the, there's a 6730 standard. There's different standards that you can pick for functional safety. So there's no predetermined ASIL or SIL level that's denoted. There's just specific requirements for that type of product. And it's usually done through a hazard analysis. But there's no specified rating as in some other applications. But that's a good question and something that we could also follow up on with more information.
So our next question is from Matthew Knight. So for AC vehicle to grid codes such as EREC G99 in the UK seem to consider the combination of the vehicle with the bi-directional converter and the EV SE together. So do you think the standards grid codes as they are currently create the possibility of interoperability barriers?
Yeah, so there's actually work being done at least on some of the North American standards and committees, and I think that probably will carry over to some of the European standards, where UL 1741, for instance, there's actually a supplement C that is being worked on. It's not released yet. There is a draft, I think, that was released, but it's exactly for that application. It's reference. It's for kind of ecosystem where the electric vehicle itself is exporting AC power, and then there's some interconnection device. So there are probably gaps in the current standards on how that's being addressed, but that's why there's efforts to update that or even add additional standards that will cover that type of application.
Brilliant, thank you. Well, I think that's all we have time for. Apologies for any of the questions that we didn't get round to answering, but I'm sure Mike will be happy to answer any off camera. So thank you again, Mike, for a really interesting Q&A session and presentation. And thank you also to everyone who was watching at home or in the office or wherever you are, who joined us and contributed to the webinar. But for now, that's all from me. And I hope you have a lovely day and keep an eye on current for our next Briefings webinar. So thank you, everyone.